Thank you very, very much for the introduction, Wayne. You're too kind. I'm just going to jump right into it. I have a little presentation that I'll go over, um, and then we'll have some live demos and introduction to different tools that you would normally use to hack cars. Um, So, a little bit about myself. I just graduated college. I'm part of the car hacking village, where we love hacking cars at DEF CON, Black Hat, you name it. And you can also come in and actually test all these skills that you've learned through this course on our CTF and on some of the cars that we'll have over there, just in case you're not comfortable hacking your own car. Um, because to be honest, things can break and cars are expensive, but it doesn't mean that you should not try any of these. So some of the attack vectors on, oops, so some of the attack vectors that come with modern cars um, are plenty. So in the past, everything that you could do on a car was initially through the CAN bus or the keys. The CAN bus is essentially the messaging system or the backbone of the whole car. So everything from your brakes, your lights, to even sometimes unlocking your door, all of that happens through the CAN bus system. It's just a way for different parts of the car to communicate with each other. Nowadays, most cars are connected. They have all these different fancy things. I like to refer to cars now as computers on wheels. So, some of the things that, some of the attack vectors rather, are wireless, such as you have Bluetooth, mobile radio, which we'll be going over, which is DAB, RDS. Then on the physical side of it, you have the OBD2, which is under the steering wheel, which we'll be using as well. And we have hardware to connect to the OBD system in order to play around with CAN. Many cars now have infotainment systems, like the car that we'll be having in the presentation here is a Honda Civic with an infotainment system running Android. Then you have telematics. Most cars now are connected to the internet. They come with fancy apps so you can lock, unlock, start, track the car, track the fuel efficiency, and get a lot of data through there. So that's another great attack vector as well. And you have other things such as radar, LiDAR, and other visual sensors. You see all these fancy sensors on Teslas. Newer cars have lane keep assist, ADAS, things like that. Then you have the black box, which again stores data in case of a crash, which you can retrieve data from later on. My personal favorite, the radio keys. You have the keyless entry systems where you walk up to the car, it unlocks, you press a button, it sends out a signal and unlocks. You have tire pressure sensors as well that keep sending information to your vehicle about the tire pressure, and just so that you don't get into accidents, things like that, which is important. And that's also something that can be played with. They have uh, a lot of research around um, fuzzing tire pressure sensors and sending falsified data, which sometimes can cause funny things to happen on the car itself. You have your reversing camera, which is sometimes often connected to the CAN bus itself. So you can unplug that, get access to the internals just by connecting to the CAN bus, things like that. Um, and most recently is the EVSE. So it's most of the EV cars now come with different types of charging, such as car demo, CCS, CCS2, and way more. And that some of them also have the CAN protocol on it as well, which you can physically connect to and then have fun with the CAN bus again. Um,
Okay,
and you also,
so let me ask you
sorry.
this. So let me ask you this real quick question then, right? So on these new motor vehicles, you talking about the tire pressure sensor. Let's say there was a nefarious, Russian, Chinese, whoever the criminal might be that is targeting an executive or a military personnel. Are they going to be able to let the air out of your tire with the newer vehicles, because some of the vehicles allow you to automatically fill the tire when the pressure falls below a certain threshold, right? Are they going
I
to be able?
I I don't see why not. I think it's 100% possible and feasible because none of these are very small things. I don't think any auto manufacturer is gonna go to the extent of encrypting it and actually securing it to a point where things like that cannot happen. But I 100% agree that can happen. In fact, we already have privacy issues around the tire pressure sensors itself, just because each of them have a unique ID that's broadcasted. And just using that, you can essentially track someone just by knowing that if you know what pressure sensor you're looking for, you can get a ton of information as to where they're traveling, things like that, just by looking for a certain signal. And I think there was a tire company or there was some sort of issue where uh, someone or a company or an entity was constantly looking for tire pressure sensors and then looking at how many times they were going through a toll or something like that, and the tire pressure itself, and then recommending that the owner of the vehicle changes the tire for safety and things like that. It was more of a marketing thing from what I remember, but issues like that have happened in the past. But what you're talking about is like obviously much more serious, and I think it's 100% possible.
Yeah, so these are things I was just looking at, right? So sorry to interject there. I just wanted to speak about some of these things so people get an insight as to the tire pressure sensor seems like such a small thing. How could it be related to a security thing? But exactly as you pointed out, everything is connected to a network, and you've got to be able to figure out how to get into that part of the network to control those sensors or whatever else you're looking at. Thanks.
No, no, I agree 100%. It's really scary how something this small can cause a big impact. But then moving on, you also have things like satellite connection. Now you have Sirius XM, where there were a few researchers that were able to leverage Sirius XM in order to lock, unlock, start millions of cars worldwide, which is pretty scary. Um, at least in the US, most cars use Sirius XM, and they had a feature, or there was rather a vulnerability where they were able to, walk like just open a car and do a lot of things just using Sirius XM, no RF, nothing else. Um, and moving on, I just want to get into a little theory of the CAN bus itself. Um, just because it's very important to car hacking. Just and since it's the language of the car, pretty much. So it was invented in like 1986 by Bosch. And back then it was never intended to be secure. It was only meant to be a messaging system that was efficient for the car, and you needed something almost in real time that was lightweight as well. And so this was invented by them, and um, you have the arbitration field, which we'll go over. So this is a unique identifier. Then you have your control field, the data field, and this is about all that you see. And then you have other things such as the CRC, ACK, EOF, and INT, which we won't really be looking at. But this is the most important parts of it. So your identifier usually addresses which ECU or which device you're talking to on the bus, just because there can be several of them. And then you have your control and data field that actually tell it, okay, this is what I want you to do. So the beauty about the CAN bus is that it allows different microcontrollers and different devices to communicate with each other without a host computer. A great example of this is the Car Hacking Village badge, where we have a badge that uses the CAN bus itself. We've had it several different iterations of badges over the past few years, where you can actually connect to it and then read, send CAN data, and do a bunch of different things. And An example of using different microcontrollers is that quite often we collaborate with different villages to make their badges compatible with ours just using the CAN bus. So um, it's a very versatile way of communicating between different microcontrollers. Another thing that's important is the dominant bit in the CAN bus is zero, unlike many of the other protocols where one is the dominant bit. Um, my favorite, again, the wireless stack vectors. So you have your keyless entry system. So you have the passive keyless entry and the remote keyless entry. The first one, um, it works on the 125 or 134 kilohertz frequency, where you walk up to the car and then it sends. You have different types. So you have a challenge response, and different things. So you walk up and you can hold the handle and it'll unlock. And the remote keyless entry, on the other hand, is you press a button on your key fob and it yells out the password in all directions. So you're just yelling out a password, hoping someone's listening. And in case you're the listener, you keep looking for that password constantly. And if you recognize the password, you say, okay, I know this password. Let me lock, unlock, remote start, and many more things like that. You have the infotainment system where you have the digital audio broadcast radio, where you can not only send text, but you can also send images or GIFs and text with it, along with the music. Then you have the radio data system, where you can send audio and text together, which you can have a lot of fun with. The main reason for these two, even though it might seem that it's just text and an image being sent, there's a lot that actually can be done with it. Um, just like I said, cars are computers on wheels now. So imagine if you were able to do a buffer overflow or inject certain code into the infotainment unit itself just by sending a crafted string. You could, in theory, execute malicious code. Quite often, the infotainment systems itself are connected to the CAN bus. Like the Honda I have in this presentation has the K line connected to the CAN bus itself. And there was this research institution um, that was able to inject CAN frames, essentially controlling the car just through digital audio broadcast. Because what they did was they sent either strings or data in the image that caused code to run on the infotainment that was sent to the CAN bus, which is really scary because by that you can literally broadcast signal and cause you can target certain cars to crash or things like that can happen in theory. You have over-the-air updates on most cars, which is another really big attack vector because your car's always looking for new updates to come in. And the question arises, what if a hacker was to falsify the server, pretend like it's that his malicious server or her malicious server is a real one and sends in malware to your car. And that's a real serious issue. We haven't seen, at least I don't think there has been any public knowledge about any of this exploitation happening, but I wouldn't be surprised if it happens in the future, or if it hasn't happened already.
Yeah, so this is the part where, when we look at what's going on in some of the parts of the world where, like, Russians are targeting home routers, the home routers are being flashed. I was actually in Central Europe, Eastern Europe, a couple of years ago when they targeted the satellites, right? So the Viasat satellite modems, they basically did an over-the-air update and bricked 30,000, modems that were connected through satellite. So this is the part where you're looking at, well, the motor vehicle is just going to essentially be getting an update to its infotainment system as an example. So this is going to be something I think we're all anticipating, the first outbreak of these, malicious malware firmware updates. So
yeah, it's something we don't want to talk too much about, but we have to plan for the worst case. So when we're protecting, the operating system of the vehicle, no matter whether it be a drone, using Android as an example with motor vehicles, you're doing the same thing within drones. My background is more in drones, but you're starting to see the similarities in technology. It's an operating system. So when you're trying to hack a drone, you're trying to hack a flying Android operating system. When you're trying to hack a motor vehicle, I think the consensus is you're doing it through potential Android platforms as well.
Precisely. I agree 100%. And that's the great thing about car hacking, drone hacking, and all of that. All these skills are extremely transferable. Like you can go apply these skills anywhere, literally. Like the cellular stuff, you can attack cars through cellular by using something like this. It's a USRP, and it's something called a software defined radio, where you can do things like receive, send signals, and in this case, you can also emulate a base station, and have phones and even cars connect to it. And then after that, you can use, like Wayne said, many of these devices run Android. Many Android devices also have 0 days on them, even through the cellular platform. So you can send in a payload through cellular infrastructure on an Android device, which is in a car, and that's how you get access to it. It's very transferable. In fact, cellular, I think, is a little more scarier because in the past, this technology was limited only to the intelligence community. But now you can build one by yourself, which we'll be showing you how to later on, just using off-the-shelf equipment and open source tools. And that's about all you need. Um, some of the other attack vectors are, of course, Bluetooth. We've seen several exploits using Bluetooth, where again you can send payloads. You can, if you played a certain song with certain like characters in the name, that can cause things to happen. If the image, the music album image, I forget what it's called, but you can cause funny things to happen through that if you had a specially crafted one. Wi-Fi is another, like Wayne said. Um, there's Android on all these devices. Again, you have the same attack vectors as a phone almost, or a smart tablet in this case. So you can certain infotainment systems, while in the development stage, it's a known thing. I think it happened on a Mazda. They had it a few years ago at the village. But then during development, um, what many of the developers do is have it set to connect by default to a certain Wi-Fi. So the thing with that is it's great in development, and it's not really an issue then, just because they have so much to work on and so much to test. And quite often they're focused on features rather than security. Um, so what happened was someone found out that this is happening, and they were able to spin up the same Wi-Fi name and the same network that the device was looking for. So anytime you broadcasted that certain Wi-Fi network name, the infotainment would connect to it automatically. And the problem with that is, after that, once you're on the same network and you're able to communicate with someone, it's just a matter of time between you actually getting to um, hack it or get an active exploit on it. Like some of the infotainment systems, I think it was a Peugeot. It had Telnet open on it, so you could connect to it, run remote malicious code. A bunch of things happen, which is quite overlooked. And then my personal favorite, GPS. I think Wayne can speak about this a little. He's had a lot of experience in GPS, especially given that now this is a big issue in the Russia-Ukraine conflict, and even flights are having issues with navigation.
Yeah, so that's again another key point when you start looking at whether it be GLONASS, or it doesn't matter what GPS system, whether it be China, Russia, it's essential to understand that it's your global positioning system, right? So your autonomous vehicle, when you're looking at a lot of the EV or electric vehicles, they need autonomous capabilities, right? Auto drive. And it's the same thing when you start looking at drones. When the drones are pre-programmed with a flight path, they need to know exactly what position they're in to obviously get feedback. Okay, I've got to fly, south for 4 miles as an example. It's like a bird. When I've had drones up in the air, honestly, it's been crazy because the birds start having their GPS system interfered with a drone, because the drone is flying in their airspace essentially. And at first I didn't realize it, but it was hilarious because these drones were being dive bombed by birds like seagulls if you're near the coastal. So I was getting these like birds dive bomb the drones because the birds had their GPS system interfered with, right? So if you can do that with a motor vehicle, you got the exact same risks as you do with any other vehicle that uses a GPS system.
I agree 100%. It's really scary. Um, but it's again with GPS, GNSS, and any sort of spoofing. Again, same thing as cellular. Earlier, it was limited to military, things like that. But now you can do it with off-the-shelf equipment and an amplifier, and you can essentially shift a whole city to anywhere. And GPS messes up with timing, lots of different things, and it's the implications of that are really big. I think I already went over telematics, and we'll be going through like real life problems that we've encountered personally with telematics later on. And same with TPMS. Another thing that's really important is vehicle to everything V2X. So as cars are getting more smarter, um, cars are going to need to start talking to each other at some point or the other, and to prevent accidents. So in case there was an accident up ahead, your car already knows that you're supposed to brake, and then you can also do things with traffic lights. So your car can sync up with traffic lights, and then maybe a city can manage traffic in a better manner. You know, enhance the timing, make it more efficient, things like that. And that's also an attack vector. Anything, in my opinion, anything that communicates with any other device or person, I think can be hacked if you just know how to. Um, you have things like ADAS, which is at the front of the car, which is often connected to the CAN bus itself, and other things such as RFID and NFC, where some cars now you can go put your phone on it, and then your files sync, things like that. And there's also data transfer in it as well, um, which can be exploited as well. Then you have EV charging stations, which we'll go over again, where again, EV charging stations again are just computers that it's a fancy power bank in my opinion. But once you can hack that, you can essentially send, if you're using a certain type of charger that also has the CAN bus on it, so you can send CAN messages to the car, essentially controlling the car. You can deliver payloads through it. You can do a bunch of things, which is 100% possible. And the problem with charging stations is that it's connected to the power grid. So if you have access to a bunch of them, you might be even able to draw more power than the power grid can provide in some cases. Shutting it off, you can you it's there are a lot of things that you can do on the power grid side as well as the vehicle itself. Um, I'm just gonna go over the Flipper Zero real quick. It's been the most widely spoken of hacking tool, um, or rather research tool. Um, it was about to get banned in Canada, but then there was backlash in the community just because it did not really contribute to vehicle theft. And some of the things that it has is, in my opinion, I think this is a great tool that everyone should have in their arsenal just because you can do a bunch of things with it. Personally, I carry it around with me at all times. Um, but some of the things that it has is your GPIO headers, so your general purpose input output, where you can do SPI, I2C, various different communication protocols just through it. So many a times you can use it as a logic analyzer to see. You can use it to reverse engineer a device. You can use it to connect to different types of microcontrollers, program it. You can program at mega controllers, for instance. Um, you can use it as you can use the GPIOs, and you have these external boards, such as an ESP32. Then you have the MaxProof board and a lot more, where you can actually add more capability to the flipper itself. And the coolest thing I've seen with the GPIO is the ability to open up a safe in under 10 seconds or something like that, which I think was really cool. You can add infrared blasters to it. And where I've seen someone send out on an older traffic light, but they were able to emulate um, the infrared transceiver on top of law enforcement or medical cars, where once the siren's on, it sends out an infrared signal at like 14 hertz or something like that, depending on the urgency. And that's how the traffic lights turn green. So in the older traffic lights, um, it was easy to do it, but now they have a lot of encoding where it actually sends out information on the transponder. And all of that was done in a very controlled environment, which made it fine. But those are some of the things that you can do. Um, you have there was also some work using the GPIO to implement the CAN bus on the flipper, so you could use the flipper to essentially send CAN frames to the car. Um, Moving on to the infrared receiver, some cars, I know the older ones have remotes, so you can use the infrared to turn off the infotainment, turn on the infotainment. And I remember there was this one car where you could uh, turn the AC on and off, turn the wipers on and off, which I'm not sure why they wanted on a remote control, but you could do it with this. Um, and the most important part in with the flipper, my favorite is the sub gigahertz antenna, just because the keyless entry systems that I was talking about earlier, the remote keyless entry systems, most of them operate on 315 megahertz, 433 megahertz, 868 megahertz, and I think it was 968 megahertz, depending on which part of the world they're from. So in the US, most of them tend to use 315 or 433 or 868 if you have a German car. Um, and the flipper is able to actually listen on all those frequencies and also transmit on all those frequencies. Um, we'll have a video demo of actually unlocking a car just using the Flipper Zero and nothing else. It uses USB-C, so you can charge it anywhere, and you can also use that as a bad USB to deliver payloads to any machine, and sometimes even other devices like ATMs, where if they have a USB port, most ATMs and devices like those, they run Windows 7 or sometimes the Windows XP. So you could use a device like this just to send keystrokes to exit out of that application. I've seen a lot of funny things happen at DEF CON where someone was running, I think it was Doom on an ATM. I'm not sure. I've seen Doom on a tractor, which is really cool. Um, and all of this is powered by an STM32, which is one of the most widely used microcontrollers for everything. It also has an RFID board that does NFC and 125 kilohertz RFID. So you can clone MyFair cards, you can emulate the UIDs, you can clone um, uh, several other types of NFC and RFID. You have HID, which are some of the most common access control cards used across the US. And you have iButton as well, which used to be used, I think, a while ago. I've never seen one in real life and never gotten to play around with it, but that's another thing that can be done. And one important thing to note was with the RFID, or rather the whole device itself, um, you're not going to find a 0 day with it or anything extreme. It's more of a hobbyist tool where you can go learn about things, which is great because it already has everything on it. You don't need to learn the entire architecture of a MyFair card in order to be able to clone it. You can learn everything step by step as you go.
And here's a quick question. What's your favorite firmware? Because what people also should be aware of, like, you can't use this if you're using the standard firmware, you can't do certain attack vectors because it's not going to allow you to replay those malicious attack vectors. So what's your favorite firmware that you like running when you're doing motor vehicle hacking?
That's a great question. I don't really have uh, a favorite film. I keep jumping between Unleashed, Extreme, and then any new one that pops up. Sometimes I also compile my own just because there are a few things that aren't there available. So like fuzzing, HID, in certain things, you have like the standard HID fuzzer, but then um, I built like a simple program to fuzz um, a certain fuzz it in a certain way to be used on a pen test. So I keep hopping between them, but I think Extreme is great, and all of them are open source, free, and each of them have their own advantages and disadvantages. You'd mentioned certain frequencies, so by default, the flipper, because of FCC regulation and other things, you're not allowed to actually transmit on certain frequencies. So by using unofficial or open source firmwares like that, you can transmit on certain restricted frequencies. You can use this as a jammer for anything under 1 gigahertz as well, which is fun. But you also have to be really responsible because some of the medical devices also operate on the same frequencies. So you might hurt someone in the process of doing so.
Yeah, so don't go messing around when you're near a hospital, as an example, where a patient's going to come and see a doctor and get their firmware updated for their, whatever monitor they're using. So whether it be, a fitness tracker in simplistic, but then you got the folks that have got like serious, pacemakers and stuff like that. You don't want to start messing around with their pacemaker firmwares and doing jamming of the signals and all that, because yeah, could be pretty severe. And on that same note, FCC, the fundamentals, when you want to start sending signals, most people don't always know this. Whilst it's very easy to learn a video on YouTube and go and do it, you got to be very careful where you are physically located, because if you are not a licensed ham operator, you're not legally meant to be rebroadcasting anything on the spectrum.
Definitely, I agree 100%. And even with things like GPS spoofing, it's all right to do in a very controlled environment, usually a Faraday cage or an anechoic chamber where none of those signals are going to go out because you just don't know the implications of it. There could be, I don't know, maybe a point of sale system that requires GPS time in order to actually do a transaction. And if you're spoofing GPS, the timing's messed up, and then um, you know, transactions won't go through. It would cause harm to NTP and several other things. And just to since you'd mentioned hospital, the funny thing with the flipper is that you can actually, if you're near a hospital, you can actually receive data from pagers and actually page people in the hospital. So quite often, if you're near a hospital, you can see what data they're sending to each of the doctors and nurses, and also page them just using the flipper, which I think is funny, but um, there might there might be a potential implication over there just because there might be patient data going over it. And it really depends on what they send over it. I'm sure there's a law around it, but it's something that you can also look at. Here's actually a waterfall graph of the key fob and the flipper. So in this section, you have the key fob for a Honda Civic, uh, and right above that, you can see the flipper retransmitting that signal at the same time, right after, rather. So if you see carefully, this key fob in particular, you see like two spikes over here, and just by this, you can already tell that it's using frequency key shifting, which is a way of transmitting data over the air. With a flipper, you don't really need to care about it too much, and which is why I really like the flipper, uh, because you can learn about all these different things without actually having a formal education in it. You can, I personally don't like theory, and I like learning things hands-on just like everyone else. So you can actually go try it for yourself and then understand, oh, this is how it works, this is why it's like that, which I think the flipper is great for. So if you see, the flipper is able to retransmit the signal at the same frequency, and you can see it's a little noisier because you're picking up the frequency and then retransmitting the signal. And the chipset that they use a little bit noisy, as you can see over here, unlike the key fob, which is short bursts, very nice picture, but unlike this, but it gets the job done, which is really important in our case. So I'm just going to go and play a video of actually unlocking a Honda just using Flipper Zero. So I apologize for the sound. That was the Boston tea at the back. But if you see carefully, um, once you hit send on the Flipper Zero, you can see the car lights actually flash, showing that it's been unlocked. And with this exploit, this is only possible because the Honda in this video is using something known as a fixed code. So remember when I said when you're using these key fobs, it's shouting out a password. That's what happens over here. So when you use these key fobs and you press the lock, unlock, or even the remote start button, it's essentially yelling out a password in all directions, saying that, or lock, unlock, or start. And in this case, the flipper was listening on that frequency, and it picked it up, and then you can retransmit it. The problem with this particular car was that it was using the same password over and over again. It's like constantly yelling the same password again and again. So if someone's listening to it, at that point, they can just go say the same password again, and it would unlock the car. Um, and we had a similar Honda at the car hacking village, I think at DEF CON 30, where you could come with your flipper, hack RF, or anything, and actually test out the capability of this exploit on it yourself. Um, so moving on to the infotainment. So the same car in the video uses an infotainment system that's running Android 4.2.2. So you're able to root the device and get a shell on it. And after that, you're also able to so in this case, the car currently has um, Meterpreter shell on it. So every time the car starts, or the infotainment system starts, it searches for a certain Wi-Fi network, which is by default, or you can connect it to something like Xfinity in the US, and then it phones back home every time, which is not the best idea, but I just did it for fun. And like while this car runs Android, there are many other architectures like QNX Linux. Um, and in this case, it was using an ARM 7L, as you see over here. And very often, at least in these cars, they are outdated. I think Android 4.2.2 came out. I'm not sure, maybe 10 years ago, really not sure. But how old was this, Wayne?
Yeah, it is. It's this is so funny that you point this out, because what they don't always do is they don't always update the operating systems or the firmware. So when you look at like that, that is older than 10 years, because we right now on like Android 16, 17, depending on, if you look at a new Google Pixel. But yeah, there's a lot of weaknesses, specifically looking at the 4.2. It's not 4.3. There were a lot of weaknesses before 4.3 came out.
Yep. So just like that, you have all these vulnerabilities, and then once you have access to it, you have access to a bunch of more things that you can see. Like you have access to the telematics app. You can go see their Wi-Fi app, their Wi-Fi service. There's more telematics. You have your VPN on it. You have your vehicle manager. And then so the idea of this is to essentially, once you have access to this, you can reverse engineer it and then see if you're actually able to send CAN messages. Because on this infotainment in particular, it's you can use it to start, you can use it to turn on and turn off the AC for all your climate controls and things like that, and then actually change a few settings of the vehicle. So you could trigger those functions and see what's actually triggering those functions, and then you could possibly do it yourself. Because once you have shell access on it, you can just run remote code and essentially connect to the CAN bus of the vehicle in theory. Um, so once you're here, once you are already on the infotainment, you're already in the system. At this point, you can honestly listen to what's going on in the car. You can track someone, and also the CAN bus, which is the most scary. I'm gonna jump a little into the wireless, which is the radio data system and the digital audio broadcast. So over here, we're using a hack RF on the left with a PortaPack H2, where it's like the flipper, but it only does RF from about 1 megahertz to all the way to 6 gigahertz. And you can do a lot more with it. With this device, you can do GPS spoofing, you can transmit FM stations, and a bunch of more things. Um, so over here, you can see, oops, you can see that we're transmitting text onto the screen. So you can send like percent symbols like Mazda's in this case. What happened over here was there was a radio station, I think somewhere in California, where they had a percent symbol in the name of the song, and that caused all Mazda's infotainment systems just to crash, and no one knew why. And then people found out that it was because of the percent symbol, and that was a lot of fun because if you went in and broadcasted a percent symbol, you would brick someone's Mazda's infotainment system. And the only way to fix it was to actually replace it, which was pretty scary. And then the DAB security. So the company I was talking about was the NCC group, where they were able to broadcast um, text or images through the digital audio broadcast system and essentially control the vehicle itself. I'm gonna jump out of this and quickly introduce you to something called as Dragon OS. Uh, which is really awesome. It's another tool that is great. It's an open source it's an open source sorry it's an open source operating system that is designed for software defined radios. So just a sec. Yep. Wayne, are you able to see my screen?
Yeah, perfectly. Awesome.
All right. Perfect. All right. Um, so I'm just going to go over the gist of Dragon OS. So it's essentially a Linux machine that I personally run it as a virtual machine. And it has all the software you need, all the drivers, everything you need in order to get into wireless hacking or RF hacking using SDRs or anything else. So you can do everything from GPS attacks. You can do everything from Bluetooth attacks, Wi-Fi attacks, um, and even more. Um, I think um, we'll also dive a little into GNU Radio, which is my favorite tool in order to do anything RF related. It's a really simple block-based software where you can just drag and drop different blocks and essentially broadcast your own system um, of like you can spoof GPS through it. You can broadcast your own FM station, do replay attacks, and a lot more. So some of the tools that are my favorite over here is, of course, Wireshark. I don't think any uh, I don't think you can do anything network based without Wireshark. You have GNU Radio on this. You have uh, other several different things, and I just realized I'm looking at the wrong thing. Oops. Wow. Okay, there we go. I'm just gonna go
Yeah.
over that all again. But a quick overview on Dragon OS. It's an open source Linux machine that you can download. I personally run it as a virtual machine, and it's an essential to get into car hacking and more than that, wireless hacking. So the main reason for that is you have all these different tools that you need to install, so many different dependencies, things like that. And quite often installing those itself takes up a whole day, and sometimes the dependencies match, they don't, and it's really hard to work with. So shout out to Sim Executor. He made this operating system and maintains it all by himself, which is pretty awesome because you can hack almost everything with it. You have GNU Radio on it, which is my favorite tool for wireless hacking. So if you don't have a Flipper Zero and you have a Hack RF or any other SDR, you can do replay attacks through it. You can spoof GPS. You can do V2X also through it. You can spin up your own cellular base station. You can do Bluetooth based attacks, Wi-Fi based attacks. It's endless. Um, so some of my favorite tools over here is GPS SDR SIM, which we can use to spoof GPS. And like you saw in the picture over there, you can spoof GPS and send vehicles in a place where they're not, or drones, things like that. Uh, you have GSM Evil. So in countries like India, where they still use GSM, you can actually sniff GSM traffic going over the air and decrypt it even. Just with this, you can see messages going over the air. You can decode calls as well. It's a lot of fun. You have Auto Calypso BTS, which is another base station. You can see satellites through this. You can hack smart meters, or rather see what data smart meters are sending if you want to understand how it works. You have spectrum analyzer. You have Hack TV GUI, which I think was you can broadcast your own TV channel using a HackRF or any other SDR. Um, you have your Bluetooth ciphers, um, and you have things like the RFCat software on here, which is similar like the module that was there on the Flipper Zero. It's a sub gigahertz transceiver, which is also great to use. Um, and you can receive and send signals so you can decode it. It's great. You have Clever Jam. So sometimes when you're spoofing GPS, most devices like the newer phones and cars even, they use a constellation of satellites in order to place where it is. So even if you're spoofing GPS, the car can pick up um, the data coming from other satellites and then determine that, oh no, GPS is unreliable, let me use this. So you can use this to spoof GPS at the same time and also jam other bands. Sometimes even you can even jam Bluetooth on it. I've used it to jam Bluetooth low energy for a project in college, which was a lot of fun. Um, and then you have IMSI catchers where you can pick up people's IMSIs if they're on a GSM network, um, and a lot more. I'm gonna jump into uh, GNU Radio for a bit, and then show you how it works, and then show you how you can actually transmit your own FM station. So they have an awesome tool in here. So you can just go GR. Um, so over here we have GR RDS, which is GNU Radio RDS. So they already have flowcharts of um, how you can use this tool to transmit your own FM station. So just give it a minute. Um, so quite often this is a little complicated block diagram, but you don't need to worry because all you need to do is modify a few things in here and you'll be able to get it running in no time. So they've already done all the hard work for us by adding in all these blocks, writing the code for it, which is amazing. And all that we need to do is modify the parameters like what sort of audio source that you want. You just need to set it here, and you have wonderful documentation for it, and you can transmit it through any of the things. So let me go through a very basic program. So if you're receiving, um, sorry about that. Yeah. So if you're receiving anything or transmitting, you can use either an Osmocom sink or a source. So in this case, we're going to take it as a source. So let's say we were planning on capturing an FM station. So all we need is define an Osmocom source, and then you can do something like a Qt GUI, and then have this connected to it, uh, and then have a sink as well, a file sync, just to save everything in there. So the idea of this is that you have your Osmocom source. You can go in and say that, okay, this is the type of output that I want. This is the device argument. So if it was a HackRF, you go in and type HackRF and then the unique identifier for it. Quite often it picks it up on its own, so it's not something you need to even worry about. You have your channel frequency, so you can actually look. There are several websites where you can look up the radio stations around you, and then actually be able to tune into a specific one. So in this case, we can do something like 99.5 megahertz. Uh, and the thing with GNU Radio is everything is measured in hertz, and they use exponential numbers, scientific numbers, sorry. And so if you were doing something like 99.5 megahertz, you'd have to do 995 E5 or E6, and things like that. You don't need to mess with these at all. I think in most cases, uh, these are perfect. And then you can also sometimes set your bandwidth. This is very dependent on what hardware you have. So like the HackRF can do about 20 megahertz of bandwidth, whereas a USRP can go up to 40 megahertz of bandwidth. And that's essentially um, how wide of a range you can listen to. So you could probably do something like if we were centered at, let's say, 100 megahertz, you would be able to do you'd be able to capture everything from 90 megahertz to 110 megahertz if you were using a HackRF, since it had a bandwidth of 20 in total. And the same would be if it was a USRP, you could set this to 40 and do something like even lower, like 80 till about 120, I think, if I have my math right. Um, and then if you were to, uh, sorry, if you were to run this, uh, you can simply look at the data coming in, and you'd be able to save the file as a raw file to your computer, and then you can also replay it and things like that. Um, so coming back to RDS, you can actually just modify things like your encoder properties. So you can set it to which region you're in. You can set it to the different predetermined types of programs that are there. All of this was actually built into most of the infotainment systems just because there's a standard for this. Um, my favorite one is the alarm emergency one, just because many of the infotainment systems are programmed to constantly look for channels that are broadcasting the program type as alarm slash emergency. Because in many countries, I think Amsterdam, I remember someone telling me that their car would always switch to an alarm slash emergency channel if there was an accident, because their law states that every car is supposed to tune into this in case we need to make an announcement, things like that. You can set it to music or speech, which is just, again, predetermined things in the standard itself. You can set your program station's name. So you can set it to something like Cyber 2 Labs, and that would work. You have your alternate frequency one, which is the frequency you'd be transmitting on. So in this case, it's 89.8 megahertz. And I think FM stations go from, I think, about 85 megahertz till about 105 megahertz, if I'm not wrong. Um, and these are some of the other things that you can just set. So some of your country codes also sometimes factor in. So depending on where in the world you are, some infotainment systems will not automatically tune into it or show the right type of information, because each region has a separate um, configuration, or standard rather. Um, and then this is the most important part, which is the radio text itself. So over here, while this is set to say something default like radio, you can fuzz this. So you can do something like a percent symbol, a caret symbol, just try a bunch of things, and you never know how the infotainment system on the other side is going to be able to handle and parse any of these strings. So something that we'll be showing later on is how to build an RDS transmitter just using a cheap Raspberry Pi, and how you can actually fuzz it yourself using other different tools that work based on GR RDS. Um, and you can change your audio source here, and then also if you had a USRP, you can connect it to that, and that's all you need to work with this program essentially. Gonna move back to presentation.
Yeah, and so for this session, we don't want to go too far and too deep. I think this is going to give everybody a good, platform to start their research into motor vehicle hacking. And obviously, we're going to have other sessions where, sharing is caring. So we want to bring you some of the fundamentals to help people get into this, because the big issue is it's a community issue, right? That everybody's going to be affected by this. So the more people we can get researching to secure the infrastructure more effectively, the more safer it's going to be for everybody. So let's give you another 5 more minutes, Ayyappan. You've done an amazing job. But what are your final words that you want to give to the new interested persons when they want to get into motor car hacking?
Um, Specifically for motor car hacking, I would say read up as much as you can. You don't need to know too much about the canvas. The canvas is there. There are several vulnerabilities for it already. I think keep looking and keep learning about different types of things. Like you can, like Wayne said earlier, you have many devices using Android. So if you like researching Android, you can go research that and then apply it to motor car hacking or anything. If you like RF, you can learn that and apply it. I think the best thing to do is keep researching, keep trying to mess with things, and um, yeah, that's about it.
And what is your final most powerful tool that you have in your toolkit? Are you looking at hardware or software? Obviously, the Dragon OS is amazing, but what's your own personal, for me, I like to always use the Hack RF because you've got the Porter Pack. Before we got started, way back in the days, we didn't have the Porter Pack. So the Hack RF, there's some free RF courses from Great Scott Gadgets. But what's your one and most powerful tool, hardware or software, that you use most often when hacking motor cars?
When hacking motor cars, I think it'll definitely be the Hack RF to an extent, but the USRP, essentially any SDR paired with Dragon OS, and I think you'd be unstoppable.
Awesome. That is amazing. So I want to just make sure that we thank you for your amazing insight. This is really, I think, going to be very helpful for people who want to get into motor car hacking. So at least they know what areas they can go into. So if you're somebody who's come from a RF background and you already know how to do Wi-Fi hacking, you're going to be able to extend those skills into motor vehicles when you look at how they've been targeting some of the Tesla vehicles with a drone and Wi-Fi, right? Opening up their charge port, that little flap, right? So thank you so much for your amazing time and efforts today. We're going to certainly have a lot more of these sessions where, we aim to bring you information where Ayyappan's been focused on hacking motor vehicles. I've been focused on hacking and building drones for a long time. When I first started building drones, it was really funny because the flight controllers were not stable as they are nowadays. So the general consensus whenever I'd build a drone is I knew the first couple of flights, the drone was going to be falling out the sky. When you got your reboots of your flight controller, where you mid-flight, it's pretty funny. So I've had some pretty, hair-raising scenarios where I've just built this $1,000 drone and I didn't flash the firmware properly, so the flight controller software is unstable, and mid-flight, this thing starts tumbling out the sky. This is how we learn. So don't be afraid to make the mistakes. Just don't do it on your mother or father's motor vehicle or your brother's or sister's motor vehicle, because the $1,000 drone is a little bit different to a $20,000 or $40,000 type motor vehicle. That's a little when you look at the new electric vehicles. So your research and your expertise in this field is clear. We thank you once again. Very humbled to have you on this series, and we're going to be certainly bringing you more. So any final words you'd like to say to the audience?
Keep having fun and hack the world.
Awesome. Thanks once again. Really appreciate your efforts.
Thank you very much, Wayne. Thank you for having me. It's really great.